Assalamualaikum and welcome back. We're going to look at the continuation of gravity retaining wall. For this recorded video, we're going to look at the stability calculation for the retaining wall. A retaining wall is said to be stable if a limit states set out are not exceeded. Therefore, there are numbers of calculations that we must follow in order to check for the stability of the retaining wall. First, we're going to calculate the weight and the lateral thrust. What does this mean? Previously, we have looked into the type of lateral thrust. For example, we have wind, liquid, and pressure due to granular material. That is the lateral thrust. And for the weight of the wall, for example, if you have a cross-section of the wall like this, then we're going to calculate what is the weight of this retaining wall. Because this weight will help to stabilize the retaining wall, whereas the lateral thrust will try to overturn the retaining wall. From these two calculations, the lateral thrust and the weight of the wall, we're going to calculate the moment that caused by these two. We have one, the stabilizing moment, and another one which is overturning moment. The overturning moment will try to overturn the retaining wall. It comes from the pressure from the lateral thrust. And the stabilizing moment is the moment that try to avoid the retaining wall from overturn. If you can see, the rotation that happened here, because we're going to take the moment at this point A, which is this is the toe, and B, this one is the heel. So we're going to take moment at A because the wall will overturn at this point. And you can see that the rotation is opposite with each other. Next is determination of ground position on the ground reaction. From these two forces that occur on the retaining wall, okay, we're going to look at what is actually or where actually the position of the ground reaction, because we know that the reaction comes from the force acting on it. For example, when you learn about the forces, okay, there's a force going down, then there will be a force that going up. This one we call it as the reaction. And the reaction comes from the forces yang act on the retaining wall. Because we have two forces here, so we're going to find where actually the reaction happened on the ground. Okay, meaning here lah. Kat mana? Here, di sini kah? Or it is here, or maybe here. We're going to find it from point B. Okay, what exactly the value? Next, we're going to determine the ground bearing pressure, which, as you know, there is a allowable bearing pressure depends on the ground. Okay, the ground to the, we're going to find what is the allowable ground bearing pressure. We're going to do the soil investigation and find what exactly the value kilonewton per meter square of the ground. Right. So for this one, we're going to find what is the bearing pressure that produced by this retaining wall to ensure that it's not exceed the allowable ground bearing pressure. And next, determination of factor of safety against overturning. Okay, because the wall will overturn if the overturning moment is bigger than the stabilizing moment. Then we're going to find the factor of safety for that. And determination of factor of safety against sliding. Okay, this one we're going to find due to the lateral thrust acting on the wall, whether the friction below, is it enough to hold the retaining wall from sliding. So for the first one, this one we're going to determine the position of ground reaction. First, we have the retaining wall that actually look like this, the cross section. And to make it easier for us to calculate the weight, we're going to divide it into two sections like this. That's why there is W1 and W2 here. We're going to find where exactly, as I said, from this weight of the wall. And there is an action, horizontal forces happen at the back of the wall. Okay. From these two combination of forces, where will be the position, which is we call it as X. And this is the ground reaction. So kita akan dapat berapa actually value X from B. Where the base of the soil is stepped, the weight of the soil prisms resting on the step may be included in the calculation. When you're going to calculate for the weight of the wall, okay, if you have a cross section of the wall that looks like a step wall, meaning that there is a soil that sits on the top of the retaining wall here. That's in this situation, we're going to include the calculation of the weight of the soil that sit on the top of the retaining wall. Therefore, we have W1, W2, and WS here. When we have calculated that, all those weight and moment and lateral thrust, we can find the position of the ground reaction. Dekat mana? We have a wall like this, then we're going to know where exactly the position, whether it will be here from point B, meaning from the heel of the retaining wall. At the back here, it is retained material. This is the formula. So you're just going to use the base length minus dengan the total stabilizing moment, this one, minus with total overturning moment, and minus with total of vertical forces. What is the vertical forces? The vertical forces is the weight of the wall, the total weight of the wall, because the weight of the wall, dia adalah vertical, turun ke bawah. So total RV. From this, we can find the ground bearing pressure. In order to find ground bearing pressure, there are two formulas that you need to know. One is this one, and there is another one here. It based on the position of ground reaction, X, that we calculated previously. For example, if you have a retaining wall like this, and the position of ground reaction is perhaps 2.6 meter from point B, and the base length is 3 meter. Therefore, this is 0, 1, 2, and 3. You need to divide the base to 3 parts. Okay, so 1, 2, and then 3. Right, so it looks like this. And if your X value ataupun position of ground reaction tu cuts outside middle third. Okay, where is middle third? Middle third is here. Meaning that in between 3 bahagian itu, the middle third memang betul-betul dekat tengah. And the value of X yang you kira, the position of ground reaction dia, is not within middle third. Dia tak berada dalam middle third. Therefore, when it is not middle third, you have to use this formula. Okay, outside middle third to calculate for the ground bearing pressure. However, if you get the value of X, perhaps it is inside middle third here, for example, 1.9 meter. Okay, meaning that dia berada dalam kawasan hijau itu, dalam middle third. Therefore, you going to use this formula. For this formula, first we're going to look at the inside middle third. Okay, Q A slash B equal to V over B plus minus 6V E divided with B square. Right, what does it mean? Okay, so QA meaning that V over B plus 6VE divided with B square. And QB equal to V over B minus 6VE divided with B square. Therefore, plus dengan minus ni adalah A untuk plus and minus untuk B. What is V? So V is the resultant ground reaction, meaning that ini adalah RV sebenarnya ya. It is RV, which is the vertical forces. The B adalah base length. For example, 3 meter according to the cross section yang I draw here. Plus, okay, so my plus minus 6. V adalah the vertical forces again, which is the total weight of the wall. And E adalah eccentricity. What is eccentricity? It means that, for example, if you have the X is 1.9 meter like this, and the base length of the wall adalah 3 meter. This is example. So you just take the value 1.9 meter minus 3 meter divided with 2. So that is the value, how you're going to get the value of eccentricity. Maksudnya, value X, you tolak je dengan separuh base length. Okay, and E dia takkan jadi negative. Value dia will never be negative. If you do the other way around, doesn't matter. You can also do 3 meter minus 1.9. And you will get some negative value there. Doesn't matter, you positifkan lah. Okay, because eccentricity adalah length. Length dia tak ada negative value And bahagi dengan B square, which is the base length power of 2. Okay, that is for the middle third rule untuk dapatkan the ground bearing pressure. Kalau the ground reaction cuts inside middle third. And if the ground reaction outside middle third, so this is the formula that you're going to use. And actually kalau you pakai formula ini dan formula ini, you will get the same answer. Sama saja, but I suggest that you pakai formula ini because you tak perlu kira eccentricity. You just take whatever yang you dah calculate previously untuk masuk dalam formula. So QA sama dengan 2V. V adalah the vertical forces again, RV tadi. Bahagi je dengan 3 dalam kurungan the base length minus with the position of ground reaction, X. How about QB? So QB will be 0. If you are required to draw the pressure distribution for the ground bearing pressure, if the position of the ground reaction inside middle third, it will look like this. So QA will be bigger than QB. You akan dapat some value of QA here and QB here. How about if the position of ground reaction outside middle third? It will look like this. Right, so that's on the ground bearing pressure. Now we look at the FOV ataupun factor of safety against overturning. The formula is the total stabilizing moment, meaning the moment that comes from the weight of the retaining wall, divide with the overturning moment, which is the moment that caused by the lateral thrust. Bahagikan saja and you get this value. Next is factor of safety against sliding. For this one, FS or factor of safety against sliding equal to mu. So mu ni dia tak ada nama darab dengan RV ataupun V here divide with P. P adalah the lateral thrust ataupun RH. We can call it like that. And this one adalah RV. Mu is equal to tangent delta. Delta is angle of wall friction. You may get the value of delta in the question, for example. Then you calculate the value of mu and you masukkan saja dalam formula since RV dah ada and RH pun dah ada. You will get the factor of safety against sliding. We're going to stop the recorded video here. See you in the next video. Bye.